Hey guys, welcome to brainAttic. So today we have another very fun problem from the topic of differentiability. Now this question was most recently asked in JEE Advanced 2018. There is a hint of trigonometry involved in this question as well. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. Now in this question, we are given for any positive integer n, we define a function f of f subscript n, which has a domain from 0 to infinity and range to all the real numbers. Now this f n of x is basically a summation over j is equal to 1 to n, and we have tan inverse, and within the argument we have 1 in the numerator, and in the denominator we have 1 plus x plus j in product with x plus j minus 1. Now this x is defined for all 0 to infinity, but the 0 is not included. This is very important to notice. Again, the tan inverse is defined within the range minus pi by 2 to pi by 2. Okay, now this question is one or more than one option correct type of question, and we have to go through all the options to see which one of them is correct. Now, there is a simple trick to this problem, and with which we can eliminate the few options right in the beginning itself. Now, if we see that this function f n of x is defined for x which is only defined on, which is not including on 0, then we can straight away say that these two options are incorrect, because f is not defined, the function is not defined for x equal to 0. So definitely option A and B are incorrect. Okay, now let's go ahead and check for option C and D. So we are given f n of x is equal to summation over j is equal to 1 to n tan inverse 1 by 1 plus x plus j into x plus j minus 1. Correct? So this is given to us. Now what we are going to do is we are going to replace the 1 in the numerator with x plus j minus x plus j minus 1. This is absolutely fine, correct? And this gives me now this is a very well known formula where we have tan inverse, let me say A, minus tan inverse of B is nothing but tan inverse of A minus B by 1 plus AB. So this is a well-known formula. So I'm just going to plug that in, and what I get now is J tan inverse x plus j minus tan inverse x plus j minus 1. Okay, so this is what I get. Now there is something called as the telescopic formula. Telescopic formula, or maybe approach. So what happens is that when you have an expression which says like I is equal to 1 to n, and you have something like x plus I minus x plus I minus 1, what you're left with is the first and the last term itself. We can check that in this approach itself. So what we see, let us plug in for few values. So tan inverse x plus 1 minus tan inverse x plus tan inverse, now j is equal to 2, x plus 2 minus tan inverse x plus 1, ठीक है, plus tan inverse x plus 3, now j is equal to 3 minus tan inverse x plus 2. And if we keep doing this right all the way till n, you will see that this is tan inverse x plus n minus tan inverse x plus n minus 1. So if you observe here that this term and this term cancel each other, this term and this term cancel each other, similarly this term will be cancelled, and what we see here, the second term is there, right, and here the first term plus will be there and this term will cancel. So this is what we call as the telescopic formula. So finally what we are left with is tan inverse x plus n minus tan inverse x. Okay, now we'll use the formula what I've told you, right? We'll use this formula again, and what we get now is tan inverse x plus n minus x by 1 plus x into x plus n. This, if I just write it again, would be tan inverse n by 1 plus x plus n. Okay, so we have drastically simplified the problem now, and in option C, so we have already eliminated option A and B on the right grounds. Now option C, we have to find the limit x tends to infinity and tan of f of n of x. So this is basically your f of n of x. Okay, so we are asked to find x tends to infinity tan of f n of x, correct? So we have already found that x tends to infinity tan inverse n by 1 plus x plus n. Now my tan is correctly defined, so I don't have to worry anything on the argument. So tan is defined properly within pi by 2 to pi by 2, so I'm absolutely fine on that end. Otherwise that aspect had to be taken care as well. So this is x tends to infinity n by 1 plus x plus n. So if we see, right, and x is tending to infinity and both the x's are in the denominator, there's a finite term n on the numerator, so this is obviously going to be equal to 0. So what we see, that option C is also not correct. So option A, option B and option C, all three are incorrect. Now we have to check for option D. Okay, so in option D what we are given is limit x tends to infinity secant square f n of x. Okay, now again a hint of trigonometry is what we are going to use. So this problem is both dependent on differentiability concepts as well as trigonometry. So here we see 1 plus tan square f n of x. This comes out, 1 comes out because 1 is independent of x, and we have limit x tends to infinity tan square f n of x. We have just found this out and this is equal to 0. So we just found out that this is equal to 0. So this comes out as 1. So this expression basically limit x tends to infinity secant square f n of x is equal to 1. So we'll check option D is correct. So if you do like the video, hit the like button, subscribe to our channel for more content like this. Thank you so much for watching.